The logistics of a megacity. How megacities feed millions of people without collapsing. Every morning, 20 million people wake up in the same city. They need water, electricity, food, and a way to get to work. By evening, they've generated thousands of tons of waste. This happens every single day. The question is, how does a megacity actually work? A megacity is typically defined as an urban area with more than 10 million inhabitants. Today, there are over 30 of these across the world. Mumbai, Delhi, Tokyo, Shanghai, Sao Paulo. Each one is essentially a country-sized population compressed into a few hundred square kilometers. Water supply. An average person uses about 135 liters per day. In a city of 15 million, that's over 2 billion liters every day. This water doesn't appear by magic. Most megacities draw water from multiple sources: rivers, lakes, reservoirs, sometimes groundwater. Mumbai gets its water from 7 lakes located up to 120 kilometers away. The water travels through massive pipelines, some wide enough to walk through. Before it reaches homes, it passes through treatment plants where impurities are removed. The infrastructure needed is enormous. Thousands of kilometers of underground pipes, hundreds of pumping stations, treatment facilities running around the clock. Delhi loses an estimated 40% of its treated water to leakage before it reaches consumers. Food distribution. A megacity doesn't grow its own food. Nearly everything is imported from surrounding regions or other countries. Every night, thousands of trucks arrive at wholesale markets on the outskirts. Vegetables from nearby farms, rice from distant states, seafood from coastal areas. By dawn, smaller distributors have purchased stock and begun delivering to neighborhood markets and stores across the city. This system runs on timing. Tomatoes picked yesterday might be sold this morning. The coordination involves farmers, transporters, warehouse operators, and retailers, all working on thin margins. When any part breaks down, the effects ripple through the city within hours. Cold storage is critical for cities in hot climates. Without refrigerated warehouses and transport, perishable goods spoil quickly. Many developing megacities still have inadequate cold chain infrastructure, leading to significant food waste. Electricity grid. A megacity might consume 10,000 to 50,000 megawatts of power daily. That's the output of dozens of power plants. The electricity comes from coal plants, natural gas, hydroelectric dams, and increasingly, solar or wind installations. This power feeds into a grid, a vast network of transmission lines and substations that step down high-voltage electricity to levels safe for homes and businesses. Managing this grid is a constant balancing act. Demand fluctuates throughout the day, peaking in the evening. Grid operators must predict this demand and ensure supply matches it precisely. Too little power means blackouts. Too much can damage equipment. Many megacities in developing countries experience regular power cuts because demand has outpaced infrastructure growth. This is why backup generators are common in cities like Lagos or Dhaka. Waste management. A megacity generates between 8,000 and 12,000 tons of solid waste per day. Collection happens through municipal workers, often in the early morning. In well-organized cities, waste is sorted: recyclables, organic matter, and landfill material. Much of this sorting is done by informal waste pickers who recover valuable materials for resale. The waste that remains goes to landfills on the city's periphery. Delhi's Gazipur landfill has become a mountain of garbage over 65 meters high. Some cities are moving toward waste-to-energy plants that burn trash to generate electricity. Sewage is another waste stream. Millions of liters of wastewater flow through underground sewers to treatment plants. However, many megacities lack sufficient sewage treatment capacity. Untreated sewage often ends up in rivers or the ocean. Transportation networks moving people is perhaps the most visible challenge. In Mumbai, over 7 million people use local trains daily. Tokyo's rail network carries more than twice that number. Transportation systems typically layer multiple modes: metro rail, buses, auto rickshaws, taxis, and private vehicles. A single metro train can carry 1,500 passengers, equivalent to more than 1,000 cars. Despite this, traffic congestion remains chronic in most megacities. Road space cannot expand as quickly as vehicle ownership. In Bangkok or Manila, average traffic speeds during rush hour can drop below 15 kilometers per hour. What makes all of this remarkable is how these systems function simultaneously. Water flows, food arrives, electricity powers devices, waste disappears, and people move across the city. Most of this happens without central coordination. When these systems work, they're invisible. When they fail, even briefly, the fragility becomes obvious. A power outage halts water pumps. A transport strike means food doesn't reach markets. Megacities are sustained by logistics. Millions of coordinated actions that repeat every day, mostly unseen, keeping the whole system running.